Hey, Bike Rumor guys. It's Jason with Forge & Bond. I'm the CEO. And today, coming to our factory, we're going to take you through our bike wheel that's made out of thermoplastic composites. The first ever in industry. We do it a little different. It leads to some pretty cool, unique things, and we're really glad to have you here. When we receive the material, it comes in a roll format, and it's rolled up like this. Now, it's still considered a pre-preg, but instead of being the traditional epoxy that you would see in pre-preg, this material comes in a PA6, which would be known as nylon. And very similar, again, that you're used to seeing, but it's not sticky. Doesn't need to be put in a freezer and can be left out indefinitely. So what we'll do is we'll take this material and we'll take you through the automation process here, and we'll show you as we engineer these items, where we'll take the material and put it in exactly the precise location that we want, so that we create the bike wheel that has the right feel, right compliance, right stiffness in the different applications that we want it to. Okay, this is Tyrell, my head technician on the Diffenbacher equipment. On this equipment, we go through an automated process as opposed to hand layup. And Tyrell's the guy, and he knows everything about it. So take it over, Tyrell.
All right, well, let me give you a quick rundown of how the machine works. Here we have our ATL machine, stands for automatic tape layup. We load our material, our unidirectional tape, onto a Hafner spool right here. And from that Hafner spool, it goes through our tensioning system right here. So as you can see here, this will rotate, and our dancer will keep constant tension on this tape. It'll go through this pulley system into our cutting unit right here. And the cutting unit can rotate anywhere from a -45 to a +45 degree angle. After it makes that cut, it enters onto our cutting belt right here. And that vacuum is so loud, that's why I have to yell in order for you to hear me. That vacuum then holds the tape and will transfer it over to the layup table. So from here, it'll move across into our layup unit. And this layup unit just moves up and down with a vacuum in order to place the tape to where we need to onto the table. The table then rotates and moves in a lateral movement to make sure that those tapes are placed wherever they need to. For that first layer of tape, it's held by a vacuum on the table itself. Picture a reverse air hockey table. Every layer that we have after that, it needs to be tack welded using an ultrasonic welding system. Inside of this machine, we have 12 ultrasonic welders per unit. Those ultrasonic welders will place a tack weld onto the tape in order to hold it in position during operation.
So after we come off the automated fiber placement machine, this is what the product looks like. You can see each one of these unique cards, we call them, that has been cut to the exact right shape and has the right orientation. Then you see a small spot where it's been tack welded together using ultrasound. And so what we have now is this highly engineered, highly thought out piece of material that where we've laid the materials in such a way that we're going to react to loads from the ground in a way that delivers the ride quality that we want you to have. So a lot of times in a typical epoxy wheel, for speed of laying stuff up or something, you'll see that they'll lay big chunks in sections. And as you can imagine, every time you lay that chunk in a certain section, you're not getting the same property across that bar of material. You can see that we've broken it up into little segments so that you could get the appropriate feel and the strength that you want as you hit the ground. So when you have it in a longer segment, you're exactly right in one spot, but you're not right in the other spots on the outside, but you're getting this average thing. What we're trying to accomplish here is we're getting it across every segment as much as we can that it makes sense. And you can see as this is put together, this represents about 130 different unique pieces of material, and they're in the right spot to do the job they're supposed to do.
So after we take it off the ATL, we move it over to our next process. This machine right here, it's called the FiberCon. This is our consolidation method that we use, and it's actually one of the faster consolidation methods on the market right now. In a nutshell, what this machine does is it'll pull it under vacuum. We pull it to about 500 millibar, and it'll be sandwiched between our flex sheet right here and a crystalline glass down below. Once all that moves, pulls under pressure, again 500 millibar, it'll rotate over here to our IR station. We have 10 different zones, top and bottom, for this station, so you can mirror your heat from the bottom and the top. It'll rotate into here, cook for about 45 seconds is all it takes to get to around 440 degrees Fahrenheit. And then it'll rotate over here to your cooling station. And this is just a closed system where we recycle the water through a cooling station. And these are about room temp plates. You have a bottom steel plate. You have 16 individual plates up top that are spring loaded. So what it'll do is it'll lift up and it'll just sandwich your cassette between those cooling plates for about 120 seconds. It'll then rotate out, let the pressure off, and you can pull the parts off, and it actually cools them off enough that you can just grab them with your bare hand when it's all said and done.
And the finished part from this product, it comes out like this. You can see now, as opposed to a floppy thing of multiple cards, it's a fully consolidated piece of carbon fiber. And this would represent the outside sidewall of a wheel. That'd be about a 35 wheel. And we'll show you that for the rest of the factory tour. So after we come from the consolidation press, it'll come down here where Bry will grab it and he'll load it into the velo press. And what we have going on here is we have a carriage system that will take this, and Bry's gonna load it, and you'll see us load it in. We've included some tabs in the layup that are just there for manufacturing help. And a simple clamping system will hold it in place. And then Bry will run the machine, and the carriage will run back into a heating area that's an IR heating system. And it will close out for a certain amount of seconds to allow the material to get up to the right temperature that we can then form it in the die that you can see right in front of it. You can see the press heads coming down slowly and getting ready to do the full closeout stamp. So now the material's at the appropriate temperature, drapes into the dies, and then it stamps it into shape. Now it's sitting in there right now, and all we're waiting for is a temperature where it goes back to a solid state instead of a liquid state. And when it comes out, it'll be in a rigid form that'll be ready for us to do the next operation, which will be to trim it to the appropriate shape. So you can see at this stage it's been formed to the shape of the die, and we've got these extra trim sections. And again, there is some trim there, but again, that trim is 100% recyclable, and we can use it for other items, whatever that may be, for whatever industry. From this operation, we'll head over into the water jet room. But as we're passing this, you'll also see this represents the channels that will go on the inside portion of the wheel. We take 3 pieces and we turn those 3 pieces into a circular section for the inside of the channel. In the water jet area, we have a 5-axis water jet, and we run it without any garnet. We're running it with just high pressure water, which it allows us to keep the scrap clean, and then we can use it for something else. Right now, as you look further inside, you can see the sidewalls that we've got set up. And what will happen is the water jet will run around and trim out those sections. Here in this area, we'll do the channel sections later. So after water jet, and this one's a mountain product, so it's a little bit of a smaller sidewall, we'll take those trim parts, and this would be the 2 sidewalls that you would typically see, and those parts go together in that format. And then we mentioned the channels as we walked by them previously. You'll have a channel section as well, and this channel's been formed in a very similar manner. And then we'll take these parts, and I can't quite juggle right here, right? We'll put these parts together in a format where it'll come together, and then we'll have we'll have the silicone pieces that you would typically see in a bonding operation inside of there. And we'll show you that loaded in the mold in a separate step.
To turn those 3 parts into a complete rim, the 2 sidewalls and the rim bed channel are loaded into a mold. This process is unique in that the rim's parts are literally melted together. There's no carbon overwrap or extra material to add weight. 2 bladders are used, one underneath the rim bed to create the hollow cavity inside the rim, and one on top to shape the rim bed for easy tubeless tire setup and tire bead retention. The bladders are pulled through a hole in the rim and clamped outside of the mold. with air chucks installed so they can pressurize it. While they use decals for their own rims, Trex rims have logos etched into the molds, which results in a very clean look. It's bolted shut and then into the oven.
So this mold's fully loaded up and it has those pieces ready to go. And Tanner's got he's got the bladders loaded in that come through. So when it gets up to temperature, we'll hit it with the pressure, and that pressure will create that internal pressure to blow it out against the mold. The mold's loaded into the press where it'll create a heated side where we take it up to temperature. And the thing that's super cool about it, again, all we're trying to do in thermoplastics is to get you up to that temperature that allows enough flow that we can get the parts to re-bond together. And then after that, it's how quick can you cool it off. So we take it in the heat for about 7 minutes. We move it over to a cooling press and it's in there for, you know, similar amount of time, about 7 minutes maybe. And once it gets to hand touchable that we can open it up, we'll open it up and pull that part out. And we'll do that right now. So now we have the mold has come out of the cooling press and Tanner's ripping the bolts out. And you can hear the air pressure coming out of the internal bladders. So our molding technique is a little different than they're used to seeing on the typical epoxy version. And as he opens it up, again, you can see that the surface finish of the part is already just right. So this is after it's come out of the mold, and Tanner's removing the hard blander, which you'll see creates that inside hook bead. And you can see on the outside of the part, you can recognize, you know, whose product that is, right? So the difference you'll see on our stuff versus the typical method, that's all that's coming off, right? We don't have massive amounts of carbon that we're gonna throw away. We don't have to work on it any different. It's already a perfect surface finish, as you can see. There's no pinholes, and it's not gonna go through that next cycle that you'll see in a lot of factories where there's a lot of pinhole filling and a lot of wasted effort.
Hey guys, this is Dave from Forge and Bond. Jason had to leave us, so I'm gonna finish the walkthrough and tell you guys how we get to the finished wheel. So once everything comes together, we come over here where they do the final flashing. She's actually working on something else that we make for another company here, but all the wheels come together here and they finish up all the micro flashing, getting anything off, making them look real good and pulling everything together. Once she's done here, we come over here to the robo drill, and this is where we take a finished rim and turn it into whatever it's gonna be, a 28 hole, a 32 hole, whatever it's gonna be. Then we come over here. This is a section where everything gets finished. We have two of our top people, Bodie and Shay, who actually put it together. Shay actually laces the rim up. If it's gonna be a total wheel, they're gonna put the hub and everything together here. Bodie's been doing this forever, and this is where he'll take what she did over there and actually true the rim. And I won't go through the whole process about truing the rim, but he does this all by hand. It could take him 15 minutes, it could take him 30 minutes, depending on what hub, what spokes, and what rim he's doing. And then when he finishes that over there, they come this way. And Shay, she puts all the stickers on. They basically put the rim or the wheel inside here, and depending on what it is, what type of rim, all the stickers come together. If we're just doing rims, when everything comes together over here, this is where they patch. You saw that bladder that they put inside, they pull it out through this hole right here. They actually patch that and seal that up. And then after that, it goes through one more quality assurance check, make sure everything's good, and then they start boxing it up. And these are orders for people that have ordered full wheels and rims. Some company orders a whole box, and it could be just rims only. Some order different types of rim, and everything comes together here. This is the final quality assurance check, and then it heads to get shipped and heads out to you.
Bike Groomer, thanks for coming by. It was great to show you guys around. If you want to check us out at forgeandbond.com and then on the socials as well.